Hello everyone, hello everybody. Every weekend, we are going to release our first Fox session on material revolution and her relationship with climate change issues. But we will explore and discover new vision of this material, how we can tackle this issue and exploit it and turn it from a problem to a solution. This is our goal for this session, is to raise awareness and foster sensitivity toward climate change actions, the SDG number 13. So we are going to tackle what's the problem of climate change and what's the relationship with green building, with buildings materials, how we can exploit these materials, the resources to save our planet and save the peoples. So we know that climate change, it's a big issue. It's about greenhouse gas emission and the carbon on the atmosphere. It's a big question, how we can store carbon, how we can block this carbon from spreading. Sequestering carbon that has been removed from the atmosphere in buildings and in products especially is a key way of tackling climate change. So this can be done by taking plant matter and taking more organic and mineral and sustainable materials to capture atmospheric carbon and also use it directly. So climate change is a material problem, and climate change is really a material problem. In that, we are going to discover this problem and what's the solution, how we can turn this problem to a solution. How come we can turn to that into our biggest resource? Why not? So there is many products that can be utilized like a carbon capture and can be also make a key solution and an alternative to reduce greenhouse gas emission and impact positively climate change. So let's begin by the how. Why we introduce, why we tackle this topic, especially climate change. Why? Because building, in the world of building, the world of green building services, there is 4 pillars of green building services: safety, comfort, efficiency, and climate change. That's why in this session we are going to focus on climate change, combining the dioxide carbon emission, the GHG emission, pollution, the embodied energy, and the embodied carbon. So this is the service of the building. It's to make this happen, to make this service more sustainable and going green to reduce climate change strikes. So what's this kind of emissions? What's the relation with materials that we use it in building and in our daily life? So we are going to start our session with the king of material. Is the king of material building, it's concrete. This is the king of material. It's the big famous concrete. All the buildings are built with this material, with this toxic material. Why? Because he is the king. It's the king of material. Every building is built with this material. So how we can turn it into a big carbon negative emission, a big carbon negative material? It's very simple: to produce and to make a bioconcrete. This bioconcrete is developed especially in Canada, exactly in Montreal. This is a type of concrete that captures carbon in its emission and also in its production, while substituting emission intensive in the cement. We know that the cement, it's an element from the constitution of the concrete. So the cement is responsible for 8% of all greenhouse gas emission. This is a huge amount. This is very negative, with waste slag from also when we product steel industry, especially there is a waste slag. So this process of producing a bioconcrete relies on captured industrial emission. We know that industry which produce concrete have many emission, negative emission, especially dioxide of carbon emission. That means it reduces the amount of the new emission that is being into the atmosphere. It is being spreading into the atmosphere, but does not reduce the atmospheric carbon dioxide. Why? Because it's an element of whole the life cycle of the building. So this revolution of this material that is developed in Canada, especially in Montreal, once the company draws its carbon dioxide from the atmosphere, they have developed a revolution air capture. The acronym called DAC. It's air capture, direct air capture. This kind of process make the final material a carbon negative. So we can use it, we can make use of it to build our buildings. So it's a carbon 100% carbon negative material after this capture of emission from the atmosphere. So it's negative emission. It's called carbocrete, and it developed in Montreal. This is very huge. It's amazing to know this about this revolution of a new material that take place into the building world. So we are taking carbon dioxide out of the system every time we make a block. This is very exciting and interesting to make to reduce greenhouse gas emission. So let's move to the brother of the concrete. It's the brother of the king. It's also a king, but the inner one. It's the bricks. The bricks we build our structure, our building with the bricks. I call it the bricks concrete because they are brothers. When we produce bricks, we can produce bricks that is similar to concrete. So what's exciting about this material? How we can turn the bricks that we use it into a carbon negative material. Yes, bricks can be developed to be a carbon negative material by carbonation system, and this system is utilized. It is developed especially in Australia, and many Australian companies developed a mineral carbonation which inject the carbon dioxide into industrial waste. For example, tiling, mine tiling, for example, turning it from a gas into a solid. This which can be used to create a cement bricks, and also can be creating other building materials. So this process of carbonation replicates the same mineral process that takes place in nature. It's the same natural process as carbon dioxide dissolves in rainwater and reacts with rocks to form a new carbonate mineral. It's the same carbonation that's used in industry companies. So we are trying. So the Australians and this revolutionary material that is developed in Australia is trying to embed emission into as much of our everyday life as possible. So they turn waste into a new product, and also in the same time they make money, and this is about balancing between the efficiency and values. So it's exciting that we can really exploit bricks to make carbon negative emission and impact climate change. That's the most important thing, and we can find this material, as I said, in Australia, but we can make use it also in our countries. So let's move to the queen of materials. We say the king and the brothers. The queen is the wood, is the queen of the forest, and also the queen of building material. We know that wood is the most bio-natural sourced material that the environment and the planet bless us with it. Wood absorb the carbon dioxide on the atmosphere. But what's the most exciting thing about this material? How we can turn it into a carbon negative material. Yes, let's review some statistics about the effect, the benefit of wood. We know that the fully grown tree can remove above 22 kilograms of carbon dioxide from the atmosphere over the course of a year. That's very huge. So that the mineral is carbon negative as long it's responsibly sourced. I want to repeat sourced because when it's not be sourced, then it can be a carbon negative material. So that the felled tree is compensated by new planting. We can't cut a tree and not and produce wood materials to build with without cutting also with cutting the cycle of the tree on the atmosphere. So the tree is compensated by new planting. So any carbon stored in the wood need to be weighed against the emission generated during the process of transport, the process of the replacement of the tree. So this all kind of process need to be left growing long enough so they can be harvested and also turn it into carbon storing materials. And this is our goal, is to exploit this natural resource from the forest and turn it into carbon negative materials without disturbing the life cycle of the tree, of the planet. So, however, there is one problem with the wood is the huge amount of waste that we produce, especially the industry of timber. They produce the timber to design and to build with, but they produce many waste. How to resolve this problem? Only part of each tree is used and processed, and processing timber, especially timber, generates a great amount, a significant amount of cuts and sawdust. This is whole a waste. So only around 10% of timber is recycled. It's a little bit amount. So why we don't make this happen? Just we thinking about carving wood to make a sustainable material, a really sustainable material. So this negative process should be removed. So we are cutting away stuff all the time and make the planet suffer from our waste. So this is why this revolution of wood take the wood to make it to exploit it like a carbon negative material. So we by storing the carbon without harvesting the natural and without harvesting and destroying the trees on the forests. So let's move to our next revolutionary material. After the queen, there is many revolutionary materials like the great and the famous mycelium. Mycelium is used for insulation. We know that mycelium is removed, or I can say a retardant for fire. Every building have a retardant for his fire. So the big question, how to turn this insulation material into a carbon negative material. So many startups develop it, a new exciting revolutionary negative carbon negative material in the building to create insulation that is naturally fire removes, or we can say fire retardant. So at least 16 tons of carbon per month from the atmospheric as it grows. So the mycelium is a biomaterial. It's 100% biomaterial. So it forms the root system of fungi, feeds on agriculture waste, and also in the process sequester the carbon that was also stored in this biomass. So it's a sustainable 100% sustainable material, like the experts in environment said. So it's really can contribute to reduce greenhouse gas emission and impact climate change. It's the part of the solution to make our building carbon negative buildings. So it's naturally fire removers and fire retardant. It's the best insulation material. So let's turn from using standard insulation our building to use more efficient one and more retarded fires and more restoring carbon to make our building efficient and sustainable. So when we use standard insulation, actually we sequester carbon, and this is the negative process. So mycelium insulation also its advantages about shipping product. It's very cheap in his production in custom-made bioreactors. It can be also grown in molds to create usable eco-friendly materials like packaging or lamps. So we can turn and we can exploit this insulation material to turn new eco-friendly products that we use it in our daily life. So we can also be turned into new material, including additive ones like the leather. When we use this leather, we can make a better use for handbags and clothes that is 100% carbon negative materials. This is the big advantage about mycelium insulation, that is in the first part using for buildings materials and also using to make eco-friendly products in our daily life, to make healthy lifestyle. So let's move to the second one, to an other exciting material. It's a material that many persons know about it, but don't know the efficient part of this material, how we can turn it to a carbon negative material. This is our goal, and this is the goal of this session. It's the olivine sand. The olivine sand, it's a new material. I will set the photos to know what I'm talking about. So this is the olivine sand that I was going to talk about it. So it's a mineral, 100% mineral product material that is that was injected in our earth. It's a natural material. So how we can turn this mineral material into a carbon negative one and impact the climate change, reduce the greenhouse gas emission. We know exactly that olivine is the most common mineral on earth. So it's behind his advantages. It's capable of absorbing its own mass in carbon dioxide. So when we crush and scatter the olivine sand on the ground, we can absorb many carbon dioxide, CO2. So this means it lends itself to being a mineral fertilizer and also a replacement for sand or gravel in the landscaping one. So why the carbonated version the second photo that I was talking about can be used also as an additive in the production of cement and also in the production of papers or 3D printing filament. It's innovative material. So the most important thing about this material, it absorbs carbon dioxide very easily and very rapid. So including the mineral in online library of carbon capturing material, it's the first one in absorbing the carbon dioxide. So it's a revolutionary material. Average 1 ton of olivine sand can take up to 1 ton of carbon dioxide. This is very exciting. So depending also on the condition, it's not 100% perfect. There is no perfection. So you just have to spread it out and nature will do it its job. So this is mineral on earth material. So we can really absorb it. We can really make use of it and affect positively climate change. So let's move to the most innovative and exciting material in the world of materials, climate change materials, or let's just say carbon negative materials. It's the 3D printing filament. 3D printing filament, it's innovative process that's been used from many years. We produce from the waste wood via process of 3D printed. So many additive manufacturing company develop this way of turning sawdust and turning the waste discarded by the timber and by the papers also into a 3D printing filament. So making eco-friendly products from waste, it's very important to reflect, to reduce greenhouse gas emission. So we hope that many companies, they can turn this and exploit it to stop additional trees from being cut down and save the planet, as well as preventing the waste wood from decaying or being incinerated. So we can save our planet and also we can exploit it sustainably. So which will be released the carbon is stored in the carbon. So the process, it's not releasing the carbon, but re-releasing the carbon. This is the process of 3D printed wood, and we can say that is 100% a carbon negative material. So it could save a lot of trees and save our environment from cutting down many trees. So it's a kind material and kind process, and beautiful one also with eco-friendly design products, beautiful eco-friendly design products. So let's move to our next one, and I want to say this one is very famous material. It's the carpet. We know that we use carpet in designing our interior homes. So what's the special about carpets and how we can turn it into carbon negative material? This is the question. So we know that carpet tiles, it's very used in America especially, and many manufacturers in America make it entire product range carbon negative. There is statistic by 2040, and starting with embodied beauty and flashline carpet like this one that were released also recently. So they developed this kind of material and constructed almost exclusively from recycled plastic and various biomaterial. So which the brand says store more embodied carbon that then is emitted by the product in their production. So their goal is to store the carbon. So that's why they develop this carpet tiles. So Interface describes the tiles as carbon negative from cradle to gate, they said, and it's also there is one little problem about this material. It's about the life cycle of production that is not taken into account. Yes, it's a carbon negative material, but not 100% carbon negative material, because there is an element of transport and end of life use that can be influenced, but we can't control about it. So we focus on going carbon negative, but in the way that we can control the life cycle of the production. So it's a carbon negative material and also can reflect and impact climate change and reduce greenhouse gas emission. So it's sustainable material, but there is a little element of transport and life that we can't control it. So going green with using this kind of material and discovering this revolutionary material, it's very important to know about it and to raise awareness about exploiting material into carbon negative materials. So let's move to a new material we know about that is present in our daily life and our routine. It's the bioplastic. It's the most usable material. Why? How we can turn the bioplastic? The bioplastic we can turn it also into a carbon negative material by developing a kind of element, a biochar. So the material contains a biochar, this carbon-rich substance that is made by burning biomass without oxygen, so which prevent the carbon from escaping as carbon dioxide. So this is the process of the carbon negative emission. So implementing this biochar, if you just left it on the ground and came back 1,000 years later, it would look exactly the same. There is no change about it. This is very important. Only if you were to burn it, would that carbon be re-released. So the bioplastic is developed in Germany. There is many brands in Germany that develop this kind of bioplastic material that can be used in cars, in interiors, and also in cladding. So recently they used in Germany this kind of material, especially in Munich, to clad a car dealership in Munich, with the installation storing 14 tons of carbon, the production of this material, like they said. So it's a carbon negative material and a sustainable one and a revolutionary one also to reduce greenhouse gas emission. So the next one, we talked about many materials, but the food, is it available to use the food to exploit it and to reduce climate change? Yes. When we use food, especially food waste, we can impact climate change and reduce greenhouse gas emission. How? We know that many companies developed this kind of waste food that call it solar food. It's a growing. There is growing companies that developed this kind of food using emission captured from industrial plants to create foods and drinks. So companies, they developed this kind of process. They use microbes to turn carbon dioxide into a main substance called solein. So this is the most exciting thing about the food waste. It's the solein. The solein, the carbon dioxide is injected into a fermentation tank together with hydrogen and different nutrients, and all of which the microbes consume and turn into protein that is harvested and dried, and resulting in a powder with a similar composition to dried soy that we use it in our food. So the carbon dioxide comes from industry, but could one come from captured atmospheric carbon? So if scaled up, this technology could potentially provide humanity with its protein needs while using a fraction of the land and resources used by traditional agriculture. So also we can use it in freeing up more lands for afforestation. This we can resolve this problem, and also we can resolve energy and efficiency problems by solar power and other means of tackling climate change. So we producing solein, this substitute is entirely free from agriculture, and it doesn't require an arable land or irrigation. There is no requirement about it and isn't limited by climate condition also. This is very exciting and revolutionary material taken from food. Last but not least, we are going to conclude our material issues, climate change material issues, with the last one. I know it's not the last material. There is new revolution every day and every year. Scientists and researchers make new revolutionary materials and new researches. So I'm still choosing the most revolutionary one that can reduce climate change. So the wine and vodka bottles. What's this special about this one? We know that many use wine and vodka bottles, but it's not a marketing about these bottles, no, but to discover and explore what's special, how we can turn it into a carbon negative material and reduce greenhouse gas emission. So this kind of revolutionary process is developed in America, especially in Brooklyn, that they use it, the carbon dioxide to make vodka. We know about that. So the brands breaks down a carbon dioxide with water and also catalyst in a reactor to create ethanol. And this ethanol is very negative to the atmosphere, which is then used to distill vodka. And this is very negative process. So they invent a way to capture excess carbon from the air and also turn it into ultra refined carbon. So a convertible product. They claim to misleading since the carbon dioxide is spreading among the atmosphere. So the carbon dioxide comes from factory emission, and this is the big problem. That means it reduces rather than reverses greenhouse gas emission. And our goal is to reduce greenhouse gas emission. So they invent this capture carbon from the air to turn it into a refined product. So in addition, food and drinks only offer short-term storage of carbon, and since the product is consumed and the carbon returned to the atmosphere via natural carbon cycle, and this is the natural carbon cycle. They capture excess carbon and return it to a refined one. This is the sustainable emission, the sustainable process about this bottles of wine. So I know it's very exciting to explore this kind of materials and how we can exploit many resources and many materials to turn it into carbon negative material. So we discovered that it can be done by wood, cork, hemp, algae that has captured atmospheric carbon via photosynthesis or using directly. So we can really turn many materials that store carbon more permanently. So what if everything we are surrounded with was removing emission instead of releasing them? This is the eco mindset and eco-responsible mindset that we want to foster about it and raise awareness about it, which make carbon negative really a solution to reduce carbon greenhouse gas emission and impact the climate change and also impact forests and agriculture. So material is called carbon negative material because it contains more carbon than was emitted during the material manufacture and use. So that's why climate change is a material problem. And that's why we can really impact climate change by reusing this material. So I exposed some example of carbon storing material from our archive and from the research and statistic. And next time we are going to explore more miracle material that could be removed from the atmosphere and put it to use on Earth to save our planet and also save the environment. So together we can make this change and we can protect the Mother Earth by turning this and raising this eco mindset. We can, you, me, and many peoples among the community and global peoples can be sustainable heroes to raise awareness about that and be also carbon negative heroes. Why not? Because the climate change problem, it's the most big problem and the most big issue that the planet face and the most big challenge that we face as human being. So I'm going to conclude our mission and our session by a simple collective share: learn, reflect, and share. Yes, this is our mindset, is to learn and to reflect and share, to spread this awareness and to spread this sustainability action and green action among the world of buildings, and especially in the channel green building world. So you can be a hero like Superman hero, and we can be also a climate resilient hero to impact our planet and also save it and save people health. Thank you so much for this session, and see you soon for next session in our channel, Green World and Sustainable Green Building World. Thank you.